Okay, so now we're going to be able to solve. When we say solve, first of all, there has to be an equal sign somewhere or an equality sign somewhere. And we do see it. We do see the equal sign in this case. And I'm trying to solve for the letter, the value of the letter that makes this statement true. Now, what do I mean with the true statement? Something that makes sense, like 1 + 1 = 2. Right? That makes sense. That's a true statement. So I'm trying to find the value of V that gives this statement a true value. Now, what's a false statement? What's something that is not true? Something that doesn't make sense, like 1 + 1 = 5, right? That doesn't make sense. So that's a false statement. So when we're looking for solve, trying to find what's the value of the letter that makes my statements true. And then here, keep in mind, I have remember to check for extraneous solutions. So there's some solutions that don't work, okay? So to begin with, let's start with what does not work. Look at the denominators. What values of V will make the bottom, the denominators, equal to 0? Well, in this case, 0, right? So I'm going to say I can accept any value. I can try any value, but V cannot be 0. Right? The values that are not good are those that make the bottom equal to 0. Okay, so that's when it says remember to check for extraneous solutions, I'm going to get some possible solutions for V, but if one of those solutions is 0, I'm not going to accept it. And then we're going to say, well, let's cancel fractions. Right? Why don't we just deal with non-fractions? Again, I'm focusing on my denominators. And I'm going to say, well, these are pretty much the same thing. So let me multiply every fraction. Let me multiply everything by V. Let me multiply this by V, this by V, this by V. Because on my first fraction, those V's cancel out. And my last fraction, those V's cancel out. So that gives me 1 plus 4V is equal to 5. Okay, so I'm still solving for a V, but at least I have no fractions. And then what I do when I'm solving for letters with no fractions, I separate my sides through the equal sign, okay? And then I'm going to move my letters to one side. I only have one term with the letter, so that's fine. I'm going to leave it on the left side. And then everything that doesn't have a letter, move it to the other side. So this +1, let me move it to the other side as a -1. Don't forget to switch the signs, okay? So from positive, I move it to negative. If it was negative, I will move it to positive. So again, letters on one side, numbers on the other. So I have that 4V is equal to 4, right? 5 minus 1 gave me 4. To get the V by itself, let me divide both sides by 4. So V is equal to 1. I cannot accept 0, but 1 is okay. So my solution is 1. Okay, interesting. Now let's take a look at number 16. First, start with extraneous solution. So x and x squared. The values that I cannot accept, right? What the values that will make the bottom equal to 0, I'm going to say x cannot be 0. So no matter what values I get, 0 is not good because it cannot be a 0 at the bottom. Okay, so now you guys might be thinking, all right, the next step is let's get rid of fractions. The only thing is that I see an x here and I see an x squared, so they're not quite the same thing. Well, multiply it by the highest exponent. So I'm going to multiply everything by x squared. This by x squared, this by x squared, and this by x squared. Now on the second fraction here, x squared is basically x times x, right? Okay, so I know on the first fraction, the x squared with the x squared cancel out. On the last fraction, the x squared with the x squared cancel out. And in the middle, 1x with this 1x. So I have 1 plus 1x is equal to 3. Okay, now let's solve for x. I want the x by itself on the left side because that's where the x is. This positive 1, let me move it to the other side as a -1. So I get x is equal to 2, right? 3 minus 1 is equal to 2. 2 is a good solution because 0 is not. Remember I said x cannot be 0, but 2 is good. So x is equal to 2. Now let's pick up the notch a little. Let's take a look at number 17. You're like, all right, well, first of all, let me factor things out. We saw Monday, right, on the video called Factoring How to Factor. So we know how to factor already. Looking at my first denominator, I'm gonna say, okay, I'm looking for two numbers that multiplied equals -12, but when I add them is -4. I'm gonna say a minus 6, a plus 2. My second fraction is just an a plus 2, nothing I can do. And then on this last one, I'm going to factor this as a minus 6 and a plus 2. Okay, so my least common denominator, and as a matter of fact, let me write it right here. Least common denominator. So my least common denominator, it must have an a minus 6, and it must have an a plus 2. Let me start with the extraneous solutions. Okay, what values I cannot accept? Okay, I'm gonna say a cannot be 6 because otherwise the a minus 6 becomes 0, right? One of my parentheses becomes 0, but a cannot be -2 as well because then one of my parentheses becomes 0. Okay, so I'm gonna multiply. For us to not get confused, let me use blue. I'm gonna multiply everything by my least common denominator. I'm going to multiply each fraction by a minus 6 and a plus 2. The second fraction, a minus 6, a plus 2. And the last fraction, a minus 6 and a plus 2. Okay, on the first fraction, the a minus 6 and the a plus 2's cancel out, so I just have a 5. And then it says equals. On the second fraction, the a plus 2 cancel out, but I do keep the a minus 6. Let me multiply a minus 6 times this 1. Okay, so distribute the 1. 1 times a, 1 times a -6. Now on the last fraction, let's see, I cancel the a minus 6, the a plus 2, but I do keep the plus 1. Remember how our fractions need to have a plus in between them, so that's good. I have a plus. And if it had a minus, let me highlight in green what I'm talking about. If this plus was a minus, I would switch it to plus and then distribute the negative sign to a parentheses on the following fraction. Okay, so I have this. So I have 5 is equal to a minus 6 plus 1. It seems like I can combine that, right? -6 plus 1. So let me rewrite this as 5 is equal to a minus 5. Right, the -6 plus 1, I could just call it -5. Okay, just simplify something. Okay, and then again, I'm trying to get the letter by itself. So this -5, let me move it to the other side as a +5. So I get that 10 is equal to a. 10 is a good answer, so I'll take it. When I mean good answer, because remember how I said at the beginning, it cannot be 6, it cannot be -2. So 10 is okay. Let's take a look at question number 18. First of all, let me factor everything out. So on the first fraction, x squared plus 3x minus 4, right? Thinking two numbers that multiplied equals -4, but when I add them is +3. I'm gonna factor this as a plus 4, a minus 1. x plus 4, x minus 1. My second factor is an x plus 4, my second parenthesis. And then on the last one, I have x plus 4, x minus 1. So let me start with my extraneous solutions, right? The solutions that I cannot accept. When I look at my parentheses, I see this x plus 4. Then I'm going to say, well, x cannot be negative 4 then, because it will make that parentheses equal to 0. Another value that I cannot accept is x equals positive 1, because it will make another parentheses equal to 0. Okay, I think I checked for everything. Any extraneous solution, okay? So my LCD, my least common denominator. I see it has to be an x plus 4 and x minus 1. So I'm going to multiply everything by x plus 4, x minus 1. So let's see here, x plus 4, x minus 1. And then here also x plus 4, x minus 1. And then lastly, x plus 4, x minus 1. Before I start canceling things out, I pay attention to the symbol in between my fraction. It's a plus sign, so that's good. If it was a minus, I will switch it to plus and distribute it to a parentheses on the second fraction. So I will distribute it to the 2 if it was a minus, okay? But it's not, so okay, let's leave it like that. Now let me cancel what I can. On the first fraction, this x plus 4 with this x plus 4, this x minus 1 with this x minus 1, and then I just get a 2. On the second fraction, I cancel the x plus 4, but I have to multiply the parentheses that I did not cancel. So I see a 2 and an x minus 1. So let me distribute the 2. So that gives me 2x minus 2. This is equal to. Now on this last fraction, let's see, I cancel the x plus 4s, cancel the x minus 1. Let me copy what I did not cancel. So I did not cancel the 6x plus 12. Okay. Now, the left side, let me highlight with yellow. Let me show you guys this. So that equal sign separates the left side and the right side. So on the left side, let me combine my like terms. I'm just going to get a 2x because the 2 minus 2 is 0, so that cancels out. So 2x equals, on the right side, I have 6x plus 12. Okay, so let me combine the x's. I see them in different sides of the equal sign, so I got to move them to one side. So this 6x, let me move it to the left side as a minus 6x. Don't forget to switch the sign. So that gives me that negative 4x is equal to 12, right? 2 minus 6 is negative 4. Now let me divide both sides by a negative 4. So I get that x is equal to negative 3. Let me double check. Let me highlight with green the numbers that cannot be. So x cannot be 4, x cannot be 1, but we got that x is equal to negative 3. Okay, so that's good. So that's it. X is equal to negative 3. That's a good answer. Now let's take a look at inequalities. Okay, inequalities, I have more than one solution. Okay, so there's multiple numbers that will make this statement true. What I worry about are my fractions. I'm going to set my fractions, and then on one side is a 0, okay? So we're going to start with this simple. Okay, so first of all, I worry about my fractions. And then I ask myself, what values of x will make the top, and what values of x can make the bottom equal to 0? And then we're going to say, well, x, my key values are going to be, let me not write x equals. Let me just say my key values are going to be -5, because that will make the top equal to 0, right? And then +3, because that will make the bottom equal to 0. Again, I'm looking at what values of x can make the top or the bottom equal to 0. And then my key values are going to be -5 and 3. Great. Let me do a number, like a line here. And let me put my numbers in order from small to large for my key values. So my -5 goes first, and then my +3. Now, notice how my key values separate my line into 3 sections. Right, you guys see there's a section here, there's a section here, and there's a section here. So I broke it down into 3 sections. I'm going to choose a value. It doesn't matter which value, to be honest. I'm going to choose a value from each section. So something less than -5. Well, I'm going to think -6. Right now, any values, so -6. Doesn't have to be -6. You could choose -10, -11, any number that you want, as long as it's less than -5. Let me choose a number in between -5 and 3 for the second section. So a numbered in between -5 and 3. Any number, it doesn't really matter. I'm going to pick 0. And then on my last section, any numbered bigger than 3. Again, it doesn't matter which one. So I'm just going to pick 4. Okay. Now, let's pay attention to our initial question. We're going to solve for this inequality. We're going to write this in interval notation. I'll come back to what interval notation means. Now, what I mean is, let's take a look at our inequality here. If I was to replace x with a -6, because I'm going to check the first value that we think. If I think of x, if I replace x with a -6, on the top, I'm going to have a negative, right? -6 plus 5. I'm just focused right now on the sign, okay? I'm not interested in the number exactly. -6 plus 5. All I cared, again, is the symbol. Is -6 plus 5 a negative number, or is it a positive number? In this case, negative, right? -6 plus 5 is negative. Now, what about at the bottom? -6 minus 3, a negative. And I'm wondering if a negative divided by a negative is greater or equal to 0. Well, negative divided by negative is positive. Is positive bigger than 0? Yeah. So this section works. Let me put a check mark. Let me take a look at my second value. Again, looking at the equation, replace x with 0. Is 0 plus 5 positive or negative? Then I'm going to say, well, positive. Is 0 minus 3 positive or negative? Well, negative. And I'm wondering if positive divided by negative is greater or equal to 0. Let's see, positive divided by negative is negative. A negative is not bigger than 0, and is not equal to 0. So no, let me put no. This one did not work. Okay. My last number, 4. Again, looking at the inequality, x plus 5. Instead of x is 4. Is 4 plus 5 positive or negative? Well, positive. Is 4 minus 3 positive or negative? Positive. And then positive divided by positive is greater or equal to 0? Yes. Okay, so my solution is going to be representing all the sections that did work. So let me highlight in green this section. Oops, this section worked and this section worked, not the one in the middle. All right, so remember the first section was anything less than -5. Okay, so I'm just going to write from negative infinity to -5. For right now, my -5, let me close it with this bracket. Notice how my infinity, I did it with a parentheses. In my -5, let me do it with a bracket. Okay, what other section work? The last one, right? 3 from 3 to positive infinity. And let me do this both with parentheses. I'll come back in a minute. When do I use a bracket? When do I use a parentheses? Because they have a gap in between, I'm going to use this U symbol, which means unite. Okay, I'm uniting both sections. Okay, now on the symbols, when do I use parentheses? When do I use bracket? For infinities, because we never reach them, so negative infinity, positive infinity, you will always use parentheses. Now, brackets will be used when our inequality symbol, let me highlight the symbol, has the or equal to part. So for our numbers, like the -5 or the +3, we're going to use a bracket when that thing has our or equal to part, but only for the number that makes the top equal to 0, not the bottom, okay? So notice how the -5 made the top equal to 0, then put the bracket on the -5. Not at the 3, because the 3 makes the bottom equal to 0. So the bracket only for the number that makes the top equal to 0. But the inequality has to have the or equal to part. Okay. Last example, let's take a look at here, number 20. My key values, okay? What will make the top equal to 0? X minus 7. Well, think we can agree 7, right? If x equals 7, the top is equal to 0. What will make the bottom equal to 0? 3. So I'm going to do my number line. I'm going to put them from small to large. 3 and 7 are my key values. Okay, so let me try a number less than 3. I like 0. 0 is a cool number, so I'll try 0. Any number, doesn't have to be 0. Then a number in between 3 and 7. Doesn't have to be right in the middle. Any number between 3 and 7. So let me try a 4 or a 5 or a 6. And then a number bigger than 7. As a matter of fact, or as to not be afraid of decimals, let me try a 7.5. Anything. You can try anything. If you don't want to try decimals, try an 8, a 9, a 10, whatever. Anything bigger than 7. I'm gonna try a decimal. Okay, so my inequality is here. And I'm gonna check the signs, right? That's why decimals let's not be afraid of decimals, because I just worry about the signs. On the top, x minus 7. If x equals 0, x minus 7 gives me a negative. And at the bottom, 0 minus 3 gives me a negative. Is a negative divided by negative less than or equal to 0? I know negative divided by negative is positive. So is a positive less than or equal to 0? No. So this section did not work. How about 4? I'm going to try the second section. 4 minus 7 is negative. 4 minus 3 is positive. And then I'm checking if a negative divided by a positive is less than or equal to 0. I know negative divided by positive is negative. So yeah, it is less than 0. Let me try my last section, 7.5. 7.5 minus 7, it's positive. 7.5 minus 3, it's positive. I'm not quite interested in the number, just interested in the sign. It's positive divided by positive less than or equal to 0? No. In this case, only this section worked. Okay, so because my inequality symbol has the or equal to part, I will use bracket on the number that makes the top equal to 0. So my answer in this case will be the section that work. It's from 3 to 7. Bracket only on the 7, because that's the number that makes the top equal to 0. I don't have to use union, the U shape, because I only have one section. Number 19, I used the union, because we had two sections. I was combining two sections. So let me zoom out. That's what we did today.